Welcome to Calbeckistan. I'm Mr. Calbeck, and this is episode 8 of our Solving Crash Course series. If you are in Algebra 1 first semester, this is the last episode that you need for your first semester classes. However, feel free to keep watching. I'm going to have some bonus episodes that's going to give you some preview of what's to come. If you're in another class, I will have things going all the way through the end of Algebra 1, Geometry, and Algebra 2. So you can keep watching, and I'll give you some tips to make even solving really complicated problems that you'll see later in math easy. Our initial looking at this, it doesn't look that scary. We just got a pretty basic problem. There's one distribution. We got x's on both sides. This is all stuff that you've handled before. This is going to get weird when we finish it. Let me show you what you're going to see. We'll distribute. Nothing wrong with that. We'll get 2x plus 4, because remember distribution is multiplication. Then we have 2x plus 4 over here. Some of you might already be seeing what's going on with this. Again, I want to figure out which side would make this easier. I want to keep the x positive, so I could either subtract this 2x or this 2x. I don't know. Let's subtract this 2x. All right, so I've done that. This cancels out over here. And 2x minus 2x, ooh. Is that 0x? Let's go ahead and write it down. 0x. Okay, now I've got plus 4 equals 4. I'm going to subtract 4. And I get 0. So I have 0x equals 0. That looks kind of weird, particularly when you realize that 0 times anything is just 0. So my real answer here is 0 equals 0. Now normally when we solve a problem, we have x equals a number, like x equals negative 10 or x equals 3.5. But here we have 0 equals 0. The x's have been completely canceled out. And all we're left with is numbers. This is a problem. Excuse me. COVID alert, watch out. I promise I can't infect you through the camera. So 0 equals 0. This can happen on any problem. You can also see situations where you might have x equals x, or you might see a number equals number, like a 5 equals 5. These are all the same kind of answer. If you ever see something that looks like this, something that equals itself when you've done everything in the problem, the answer to this is, it's kind of a weird answer, but it says all real numbers. Okay, so that's what I want you to write down on your paper if you get that. All real numbers. And what that means is, literally, I can put any number in for x and the statement is still true. Because remember, equal sign is the same. It means these two things are the same. So if I have an x here, remember x is a blank. I could put 100 in here. What's 0 times 100? It's 0. Or I could put a negative number in here, like negative 3. 0 times negative 3 is 0. X can literally be any number. If you take a look at the number line here, hold on, I'm going to grab the camera. We can take a look at the number line. I've got one in my classroom here. We can see the number line starts at negative infinity, and it goes all the way over to positive infinity. What all real numbers means is that any single number on this whole number line could be true. X can be anything and the statement is still equal. That's what we're looking at here. So when I have a problem here that says x equals x or 0 equals 0, what I've really got is any possible number. So that's your answer. If you ever see something where that is your final answer, all you have to do is write all real numbers. All right, we'll just try this one. Again, this looks like a pretty normal problem you might see in your book or in a worksheet. Got some distribution to do, so I'm going to multiply 3 times x, 3 times 1, that's 3x plus 3 over here. And I've got 3x minus 6. And again, I want to ask myself what makes the problem easier, but it doesn't matter again, because it's the same x's on both sides. So let me go ahead and subtract 3x, which gives me 0. Subtract 3x, and again, just like last time, I got 0, but something a little bit different happens here. So I have 0x minus 6 equals 3. And I'm going to go ahead and finish the problem, get x on one side, numbers on the other. I'm going to add 6 to both sides. 0 times x is 0. 3 times x, or 3 plus 6 is 9. So I have 0x equals 9. Is this a true statement? Are 0 and 9 the same thing? The answer is no. These are totally different numbers, and they're never going to be the same. Saying 0 is equal to 9, and we call that government math. That's not true. These numbers do not equal each other. This is a false statement. These were never the same to begin with. At the very beginning, this was a false equal sign. These were not the same number. And every once in a while, you're going to see a problem that was set up at the beginning where they are not equal to each other. Okay, these two things are not the same. These two things are not the same. In that case, it doesn't matter what you put in here for x. I can put a 9 in here, but 0 times 9 is still 0. 0 times 50 is still 0. 0 times anything is still 0, and 0 is never going to equal 9. There's lots of ways that you can see this, but anytime you see something like 1 equals 2, 0 equals 9, two numbers that are not the same equaling each other, that's no solution. So instead of writing all real numbers here, you get no solution. So when you get that on your homework, I want you to just write that down as no solution. All right, that's it for today. Stay tuned for those bonus lessons I'll be putting out later. Have a good one.